Hello. Today I'm going to be talking about this circuit here, which uses an AC to AC voltage divider. Now it uses a 10-to-1 step-down transformer, which puts out about 15 volts AC, because the voltage coming from the wall is more than 120 volts instead of 12.6 volts AC at the output. Now it goes to these 4 capacitors and 2 diodes, and it divides it into about 7.5 volts AC, which is then fed into this unit, where there's a bridge rectifier right there, and it goes into a voltage regulator in this heatsink here, and there's 4 capacitors in here they're needed for for the circuit to operate. And then I'm going to a bulb here meant for 6 volts, and it'll be just used as a test to show that there's 5 volts DC available. And it'll be mounted here, and the switch there will be used to turn it on and off. And you can use it for a night light or something if you want. I want to mention that you can use 4 capacitors for the AC voltage divider, or you can use 3 like I did here. And you can see the middle one there is smaller than the other 2. And you can actually use more than 4 if you want to, 5 or 6, whatever. But it depends what voltage you want to generate at the output. And I won't be sharing the values of the capacitors and explaining it in detail until I get my file, my patent application filed soon after I complete this box, in this case, get it all mounted. And I have to solder these capacitors into strip board like I did here. And then after I'm done talking here, which I think I am, I'm going to use my clamp-on meter to show the current measurements. And there's no sense doing it on this yellow wire because the current is so small. It doesn't record on the meter because it's meant for electricians to use. They work with 120 volts or above. So I'll turn it on now and we'll test it. Okay, you can see the light bulb is on there. And hope we can show this with holding it here. So this is the input going into the voltage, the rectifier, bridge rectifier, and it shows 0.16, let's say 0.16 amps DC. Now, if I go down to the wall here, should be a whole lot less. And it is way down. Oh, 0.02 or 3. Very, very small in comparison. Oh, but it fluctuates up to 0, 8, 9, 11. Oh, I don't know why it's doing that, I don't know. Yeah, that's peculiar. So I don't know what I'm going to take for an average. Why it's fluctuating like that. Now I'll take it out of there and put it on the other wire. See if it makes a difference. I can get it on there. One wire is black and one wire is white, so that one's behaving a little less. So I would say it's about, should be saving about 50% or more. So I'll make the calculations after, and I'll post it in a comment or in the description. Now I'm going to measure it here on this green wire. It's different too. Also less. You want to take it on the other side of this transformer. Yes, it reads different too. Or maybe not. Same as the coming out of the wall. It goes way down to 0.023. So maybe it fluctuates as it's working. I think what it's doing here is when you drop the voltage down by half, it increases the current by 2, like a step-down transformer does. And probably the capacitors, when they discharge, they go through the load device. So that will cause even less current needed to be drawn from the wall. And this whole unit here is actually the load device for the AC voltage divider. And the little bulb is the load device for the voltage regulator. So there you have it. Some proof that it works and it's attainable as a power supply current saver. Thanks so much for watching.